In this video, we are studying about the total internal reflection, and total internal reflection is the phenomena which is related to the refraction of light. When a ray of light enters from denser medium to rarer medium, then it bends away from the normal. So let's say this is a denser medium, and this is our rarer medium. Let's say it's air. So it's a rarer medium, and the denser medium you can take water or glass, right? So as we have already studied about the refraction, when a ray of light enters from denser medium to rarer medium, this is an incident ray, it bends away from the normal. So angle, this is angle of refraction R, and in this case angle I is less than angle R. It means angle of refraction is greater than the angle of incidence, right? And this line is a normal with respect to which we always measure the angle of incidence and angle of refraction. Now what we are doing, we are increasing the angle of incidence. So this is the angle of incidence which is increased compared to our last diagram, right? Now if the angle of incidence increases, then what happens? The angle of refraction also increases. This is angle of refraction. And let's say in the next diagram, if the angle of incidence is increased even more, then this is angle of incidence. Now it's large compared to the last two diagrams. So what will happen? The ray of light will bend, and it will bend, let's say, to a 90-degree angle, which is quite possible. At certain angle of incidence, it will happen that the refracted ray will travel on the interface between the air and the glass. It means you can say, if you have taken air as a rarer medium and glass as a denser medium, then the refracted ray will travel on this interface, correct? So what is angle of refraction here? It's a 90-degree. And when the angle of, let me write here, so when angle R becomes 90-degree, then your angle of incidence is called as critical angle. Now this is called as critical angle, right? Now in next case, if you are increasing the angle of incidence beyond critical angle, so this was your critical angle, let's say, so this is your critical angle, and now angle of incidence, the new ray of light is traveling at greater angle compared to the critical angle, then what will happen? The ray will reflect back in the same medium. It means it will reflect back in the denser medium. So here you will find angle of incidence I will be is equal to angle of reflection R for this ray, for this reflected ray. So what we find here, when the angle of incidence is greater than the critical angle, then the ray of light reflects back in the same medium and it follows the law of reflection. It follows, let me write here, so it follows the law of reflection, right? So this is called as total internal reflection. So we can define total internal reflection as when the ray of light traveling from denser medium to rarer medium reflects back in the same medium, it's called total internal reflection. So when a ray of light traveling from denser to rarer medium reflects back in same direction in same medium, then it's called total internal reflection, right?